I think we're ready now. We get everything set up for Kingdom of Algorithmia 2024, quest number 6. Quest 6, the Tree of Titans. Part 1. On this beautiful Taxony Day? Is that a word? The tournament participants are directed to the Royal Gardens, specifically to the orchards where the trees cultivated for magical potions are meticulously attended to. Among these trees are the apples of superhuman strength, which transform anyone who consumes them into a titan of power. The cultivation of these remarkable fruits requires a specific approach, as the potency of each apple depends on whether it shares resources with other apples. Fruits with paths of the same length to the root share resources. If all branches were cut to ensure that the final paths have unique lengths, the harvest would be drastically reduced. Therefore, it was decided that each tree would maintain exactly one path to a fruit with unique length. Okay. Each knight approaches a tree and takes a moment to observe its branches. Your notes. The roots are marked with RR, and the fruits are represented by an @ sign. The remaining letters denote the branches. The notes are organized as a list of lines, each beginning with a branch name, followed by a colon as a separator. After that is a list of branches of fruits they connect to, separated by commas. Challenge for each knight is to identify the path from the root that leads to the most powerful fruit on that tree. And the most powerful fruit... is the path to unique length? Example based on the following notes. Based on the connections from the notes, the following tree can be constructed. All the fruits except for one are located on branches with the same path length relative to the root. The path to this singular most powerful fruit is RRB @. What is the path to the most powerful fruit on your tree? All right. I guess we could use this as test input. Let's create an input directory. Let's download this input. Move downloads, everybody codes into input. Let's grab this line. So I can say let lines is equal to AOC lib, read lines. I can just do that, right? And then say println lines. Let's just see if we can get that far. I forgot the input. It's in the input directory. Okay, so we got that. What I could also do is create a test input directory. And we can add this as part 1 test. Copied. Yeah. And we can try that out as well. I thought I had a little something that would allow me to switch back and forth easily, but I guess not. Test part 1. And that should also give me the smaller input. Okay, so we're looking for the answer RRB. I wonder if what I could do is instead make this a test. Right? If I say this, like this, test mod, test part 1, and put that line here instead. And we can insert equal, 0 lines len. So obviously that's going to fail, right? And if I save that, it goes back to that. And if I hit test, yeah, okay. So that worked. Let's write a little thing to parse these out now. I guess we can make a branch type, which encodes all the branches. Do we even need to do that? Or can you just get away with like a hash map that maps this to a list on the left side to a list of things on the right side? Let's put it for now in here and see what this says. Entry. Or see what it does for us. Branch. I don't know if it makes more sense to just do it as a vec, right? It could say a vec of string like that. Yeah, see, if it's only the one thing, maybe we just say struct tree branches is a hash map from string to branch. Is there a reason to have this as a branch as opposed to just saying it's a vec of string? Let's try it this way and see if it makes the code straightforward, I guess. I guess one thing we could do if we make it a branch, we could just, yeah, let's do this for now. And then if it gets too complicated, we can just simplify. Impl from stir branch. Oh, no, that doesn't work because I guess we can put the name of the branch in here. Name string. But we're going to be mapping from the name to the string, so that's redundant, isn't it? All right. I keep switching back and forth on this. So we'll say impl tree, fn new, s is as ref stir, string s self, right? And we'll just do it the regular way. So I have this as a vector of lines, so maybe that's what I should be doing. String like that. All right, and I can say for s in string, let's call this lines. We're going to split once on the colon, left, right. It's equal to s that's split once on colon wrap. And then the right side gets split on commas. So let words is equal to right dot split, comma, collect into a vec. Right, and that's a vec of stir. And if we want strings in here, we're going to have to convert. So, which is easy enough. I guess what I can do is say map s2 string, right? And now that should be strings. And then we'll say self. Oh, I guess we have to create it. Let mut me is equal to self. Oh, hash map. New. Me dot branches. Branches. Insert left into right words. Right, and then return self branches. Right. Add that. And then in testing, we want to create a tree. By saying let tree is equal to tree new lines. And then we can say assert EQ. How many entries are there in a tree? 9. I guess we could say that, right? 9. Tree branches len. Doesn't this, I thought Clippy preferred, okay. All right, it's passing now. If I hit Clippy, doesn't it complain? No, it doesn't complain. Okay. I guess that something changed. Oh, I know why. It's because I used to do this. And then it said, don't do that. It's easier to not. Okay. But we're just handing in the strings and getting rid of it, passing ownership, and then it can free afterwards. That's fine. So we can now create the tree. Can we solve part 1? And I guess what we can do is just write a little function on here. And what we're trying to do is get back a string, right? RRB at. And all we're going to see is the shortest distance. All right, first let's see if we can make all the branches. Fn find shortest self. And it'll return a string. Let's do that. And then we're going to do assert here is equal to RRB at to string tree find shortest, right? Test. Okay. I guess we start with RR. So this is just going to be a search, a basic search. We'll just construct everything. I mean, it looked like the other input was very small as well. So for now, we'll just do the brute force approach. Q is equal to back new, and then Q push back. We're going to start at RR. I guess we also need the path so far, which is a vec new. Now it's going to say that it doesn't know the type. It's just going to be vec of string. Okay. And now we can say while let some node comma path is equal to q pop front. What we'll do is we'll look it up in the branches. The current node is going to be where we start. Oh, I guess the current vector should be RR as well. Right? Because this is the path so far. And now what we'll do is we'll loop over each of the branches. Right? So we're going to get RR first, and we'll see A, B, and C. So for branch in self branches of... Oh, we do want to check to make sure we're not at, right? Because there's no at on this side. So we can say if let some branch list is equal to self branches get kernode. Kernode is a string. I have to put a reference to a string there. Yeah. This is a vec of string. Now we're going to look at the next entries. So this will be Q push back on kernode, which is going to be, oh, the branch list is going to be a vector. So we have to loop over it for branch in, and this is a reference. Yeah. Branch list, branch, comma, let new path is equal to, how do I construct? I don't want to do an extend. I guess this is what I want to do, right? New path is path clone. New path push. Branch. Is this that's a reference to a string clone. Right? And then this goes new path. There should be a way to do this in one line. I don't know how. I guess what we can do is check to see if the branch is an at sign. If branch is equal to an at, I can say aster. Do I need to, though? Let's see if I even need to. And this becomes an else. Right? We can print out path is equal to the path. And we can see what all the paths we come up with. That doesn't like that. Okay. So if you RRB and then an at, right? Oh yeah, I'm not putting the at on there. Okay, and then RRBF is there, AE is there, AD is there. Then we have CG and CH. Perfect. Okay, so we're able to traverse the paths pretty easily. What we want to do is find the shortest one now. So we can say, I guess the absolute longest one is going to be the number of entries in the branch list, right? I mean, we need to pick a number. Let min size is equal to, we could just say I32 max. Right, and then we can say if, I was going to try to pick a different number. We could actually use size, since we're doing use sizes. If path len is less than min size, then min size equal to path len, and min path is equal to path clone. Let min path is equal to vec new. And then down here, we can print len the min path and the min size. Like that. Path len. I guess we could do that. So yeah, maybe it makes sense to do this. Let len is path len. I mean, this is just for my own sanity. This is not something that you need to do because I'm sure that Rust would optimize that away like that anyway. So let's take a look at the min. Min path is now RRB and 2. So that's right. So now what we need to do is convert that into a string. So this would become, I guess what I can do is say min path is min path clone, min path push at, right? And that way we can get the whole, oops, to string. And then we can just generate it here, right? Min path join like that. Is that all I need to do? And now it works. Okay. So we can now try running it. Oh, no, we can't run it yet. Because if I hit run, it's just going to print out the lines. So let's build the tree. Let tree is equal to tree new lines. And println part 1 is equal to tree find shortest. Okay, so this is what I got for my answer. Is that right? Even wise ducks make typos. Oops. Your answer length is incorrect. The first character of your answer is correct. Well, I hope so. It's because it's RR. But it's saying it's just too short. Okay. So I guess what we can do is take a look at the input and try to guess what it might be. We have RR here. It's LB, QW, and DG. What do I have for the next one? Is LB. So if I go to LB, then FN, and FN has an @ sign. So that is short. Was it saying there's an even shorter one? So RR can go to LB, QW, or DG. And DG goes to VG. Oh, I made a mistake. It's unique path, not shortest path. That's right, it's unique path. Unique path line. So we actually have to save all the path lines and then figure out which one's the uniquest. So instead of doing this, we say if the branch is an @ sign, then what we'll do is we'll say this. And then push it on our solutions. We don't care about that anymore. And then we can say solutions push min path. And we don't call it min path anymore. Solution. And then what we can do here is, let's just print out the solutions for now, and we can see what they are. Oh yeah, and I have to actually fix the code so it compiles. Silly compiler. Demanding working code. Okay. So we have a bunch of these things. Let's print them out one by one. If I say DBG, is it going to format it badly? Oops. I don't normally use, yeah, that doesn't help. Okay. So we say for S in solutions, println S. And that way we can see them all lined up. Okay. Yeah, so this is the actual answer, right? Because that's the one with the unique size. So we need to find that. What's a way to do that? I guess what we could do is just add up how many path links there are. I wonder if this is cheating. Let mod lengths is equal to hash map from usize to usize. Right? And then what we can do here is just say length entry of solution len or default plus equals 1, like that. And then we can print out all of the lengths. Oops. Right, they all have 2s except for this one that's length 7. How does that help me find it though? Because then I have to loop over each one of them and find the one that has length 7. This is very brute forcey, isn't it? We know that there's going to be one that has a single entry. I'm trying to think about how we can, if I say lengths, min length or unique length, I almost messed up again, is equal to lengths iter filter x. And what is x? Is that the pair? Usize, yeah. So len and count is equal to 1. Or find. All right, that'll get me the unique length. Unwrap. We'll hope there is one. Oops. Oh, it's a usize like that. Okay. Sorry, it's a ref usize. And I typoed that. Oh, dot 1. There we go. Oh, and that's not what I wanted. I wanted dot 0. I wanted the actual len. Yeah. So we don't need that. Okay. So we know that the unique one is length 7. So now we loop over all the solutions and say if solution len slen equals unique length, then s return s join quote. Otherwise, panic, solution not found. Like that. Okay, so this is my new answer. Hopefully it's correct. Hey, Quack, yeah, you nailed it. That's the right answer. Global time, 268 days, 12 hours, 28 minutes, and 43 seconds, and 0.04 milliseconds. but I'm still in the top 1,000. Wow. Okay. So people are not doing this. Let's check our progress. Oh yeah. So we got 6 here and 1 star. Nice. All right. Let's check in with Clippy. Clippy's okay with this. Let's make sure the test still works. Test still works. Yeah, that test didn't help me because it found the shortest, and that wasn't what I was looking for. Okay, git status. I guess git add dot. Good enough. Good enough for me. Git commit -m. Oh, git log. Let's do it. Let's use the same format. Git commit -m KOA 2024 quest 6 part 1. Nice. Okay, let's check out part 2. Part 2. Each participant quickly locates the finest fruit on their tree and then ventures deeper into the garden where the trees stand much taller and more majestic. Once again, everyone finds themselves in front of a tree adorned with fruits that provide superhuman strength, with each participant diligently attempting to uncover the path to the most potent fruit among the tree's vibrant branches. Confident in your undertaking of the rules, you carefully jot down the intricate connections of your tree and set to work. The root is still marked with RR. However, there are many more branches to analyze. Given the tree's impressive size, describe the final path using only the first letters of each branch. Okay. For example, a path with branches RR, blah, 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 become racer at. What's the path to the most powerful fruit on your tree? All right. Is this going to be much, much bigger? It's 13K versus the 278 bytes we had before. Okay. So it's going to be this. I mean, let's run it as part using the same code. And it should be wrong, but let's see if it runs. Okay. What I was worried about was that we were going to hit a situation in the input that would make this take forever to run, but it didn't take forever to run. So what does the input look like? Oh, they're all 4 letters this time instead of 2. Okay. Yeah, all the way down. Okay. I wonder why MFRS is in green. Everything else is in, oh, there's another one. RR is yellow. Yeah, MFRS must be a well-known acronym. All right, so it's probably RRKCVK. I mean, we could peel it out, but I wonder if what we should change then is having find shortest return the actual path. And then up here we can join like that. Let me just copy this so I know what the right answer is for me. And then what we can do is have this return a vec of string. Right? And we could just say return S. We might have to clone it out because it might say does not live long enough or something. Part 2, let's do that for now. No, it took it. All right, now my question is this answer the same? LB, FND, PQ, TH, yes. All right, so we should be able to just put this together just using the first characters. So we can say iter, and we can say map branch, B for branch, branch chars, next, unwrap, collect into a string, oh, and then get rid of the quotes. Okay, let's see if that's right. Oh, we don't need this unique anymore. All right, let's see if that's the right answer. Nothing can quack you down. 779 on Global Place. Okay. It took me 32 minutes to get here. Let's check my progress. All right. I mean, the gear's there. Theoretically, I only have to solve part 1 for each one for all the gears to work, right? I imagine that another gear is going to hit somewhere where we attach to this thing and then these gears start to move, and I don't know what these gold things are doing. And here's another gear that we can trigger. And here's another gear. I imagine we'll fill in a bunch of gears over the course of the 20 days. All right. That went pretty well. Oops. Oh, right. This has to be RR toString followed by B toString followed by @toString and a vec bang. And test still passes. Okay. And run still runs and clippy still clippies. Okay, good. Git commit -am. Well, we can just go back up here, right? And put part 2. Very good. All right. Are we almost done? This is going to be a very short stream. I shouldn't say that before I read part 3, right? The final challenge takes place at the most ancient tree in the orchard, a magnificent giant adorned with countless branches and fruits of extraordinary power. Unfortunately, this majestic tree has come under attack from relentless pests, bugs and ants, which resemble actual tree branches. You make note of them along with the other connections so the gardeners can easily find them later. As in part 2, the route is marked with RR, and you should describe the final path using only the first letters of each branch. Okay. We don't have an example here. Oh, this one's 84K. Wow. Okay. But I imagine that we can just copy paste again. Change this to part 3. Change this to part 3. And then what I want to do before I save it, I want to save my answer for part 2. Oh, it does have the answer for part 2 here. Okay. I'll stick it in here anyway. Maybe it makes more sense to put them on top. Let's say my part 1 answer. Right? And then my part 3 answer, DBD. Okay. So if I run it now, ooh, I wonder if there's a loop as a result of the bugs and ants. So let me kill that. Make sure it's actually dead. So, and now let's take a look at the input. Part 3. So what are they talking about? How do you determine if there's, is that what we need to do? Is determine if there's, oh, no. There's bug, ant, bug. Okay, so I see. There's little bugs and ants in the tree, and I bet you they're causing loops. I bet you that's what the problem is. There aren't that many. What we can do, I guess what we can do is just filter them out, right? We can just go here. Are there ants and bugs in any of the other ones? Ant input. And bug. It's only in part 3. Okay. So that means if we just add something here that in the parser that says ignore this, right? We can say if left is equal to ant or left is equal to bug. Continue. And that should just work, right? Because then there's no left. Oh, no, no, no. We want to make sure we end in a, I don't know if that's going to work. Let's find out. Cargo run. I'm just thinking if we need to also add it to the right-hand side. But if we get an ant on this side, sorry, if cur node points to an ant, right? That means we're going to push it here, and then we'll look. I don't know if this is the right answer, is what I'm saying. I mean, we can try it, but we might have to filter it out here. If I say filter, we can filter it before we do the toString, right? We can just say, oops, dot filter s is not equal to ant, and s is not equal to bug. Is that going to change the answer? No, it looks like the answer remained the same. Okay. All right. You just cracked the jackpot. That's the right answer. 738. Okay. Not bad. Let's check in with Clippy. Bacon Clippy. Hit the test. I didn't have any other tests because there's no other test input to check against. That's a shame. All right. Run. And it runs really reasonably quickly. That was far easier than I thought it was going to be. Git commit part 3. All right. Yeah, a nice, quick, and easy stream for me today.